Hello guys, and welcome back to another video. On this video we'll be balancing equations. Okay, so when you balance equations, you want atoms that happen to be on the left to be equal to those on the right hand side, and this is how we go about doing that. So firstly, we check how many atoms are on the left. I'll start with oxygen because there's more of oxygen, and you see that on the left I have 2 oxygens, but when I go to the right I only have 1 oxygen. Remember that we check to the number of atoms by looking at the small numbers at the bottom, which are called subscripts. Okay, the subscript numbers are what we use to check how many atoms are present, and we see that on the left we have 2 oxygens, but this side, if there's no number here, it means we have 1 oxygen. So to balance our equation, guys, we have to take this number. Since I have 2 oxygens on the left, I'll take that 2 and put it up here, because when you balance we add coefficients, right? So I'm gonna take this 2 and put it up here, and when I do that you will see that now I have 2 oxygens, but this 2 now changes the number of what is this, sodiums on my right hand side, because I'm gonna say 2 multiplied by 2, and this is going to give me 4 sodiums. On the right I have 2 oxygens on the right, so the oxygens are balanced. Actually the oxygens are balanced, but the sodiums are not, because I have 4 sodiums on the right, but I only have how many on the left? I have 1. So I'm just gonna take a 4 this side, put it there, and now I have 4 sodiums on the left and I have 4 sodiums on the right. So the equation is now balanced. So I can now quickly write my balanced chemical equation. Say 4Na plus O2 react to form 2Na to O. So now the equation is going to be balanced. Let's look at this one, B. With B, same thing. I look for the one with the most number of atoms. So say oxygen on the right, on the left. Oxygen has 2 atoms on the left, but it has 1 on the right, so I'm gonna put 2 here. Now I have 2 on the left, 2 on the right. But with the ions, ion has 2 on the right but 1 on the left, so I have to put a 2 there. So now I have 2 ions on the left, 2 ions on the right, 2 oxygens on the left, 2 oxygens on the right, and then I can write the final equation, and now it's going to be a balanced equation. Let's move on to this one, C. We have aluminum plus oxygen, and what you will realize here, guys, is that on the left I have 2 oxygens, but on the right I have 3. So for us to balance this equation, we are gonna crisscross. This 3 will come here and this 2 will come here. Okay, that means if we do that crisscross, that means that I'm gonna put if we do the crisscross, it means I'm gonna put a 3 here, so that I have 6 oxygens on the left. But if I have 6 oxygens on the left, I should also have 6 oxygens on the right. Thus I'm gonna put 2 here. Now I have 3 times 2, that's 6 oxygens. 2 times 3, that's 6 oxygens. Now the oxygens are balanced, but the aluminums are not. I have how many aluminums on the left? 2 times 2, it's 4. But on the right I have, what am I saying? On the right I have 4 aluminums, but on the left I have 1. So when I take 2 times 2 and it gives me 4, it means I have to add 4 here. So now I'm gonna have 4 aluminums plus 3 O2, and this will give me 2Al2O3. The equation will now be balanced. Okay, let's move on to D. With D, same situation. We are checking firstly, how many sodiums do we have? We have 1 sodium, 1 sodium. How many hydrogens do we have this side? We have 2. This side we have 2 plus 1. So we have how many sodiums we have. How many hydrogens on the right? We have 3 hydrogens, whereas this side we only have 2 hydrogens. Do you see that? So guys, you can see that the hydrogens are not balanced. Okay, the oxygens are fine, sodiums are fine, but the hydrogens are not. So for us to make these balance, what I can do is add a 2 here. If I add a 2 here, I'm gonna have 2 plus 2. I'm gonna have 2 hydrogens plus 2. That's gonna be 4 hydrogens. And then you will see that the nitrogens are also gonna be affected. The sodiums are gonna be affected, and oxygen as well. So I now have 2 sodiums. That means I should also put 2 here. And I now have 2 oxygens on the right, but on the left I have 1. So I would have to put a 2 there. And if I do that, you will see that for the sodiums, they will be balanced. 2 sodiums, 2 sodiums. And then this side, I check the hydrogens now. I have 2 times 2 hydrogens. That's going to be 4 hydrogens on the left. And when I go to the right, I have 2 hydrogens, because this 2 belongs to all of them. So it's 2 hydrogens plus these 2 hydrogens. So now the hydrogens will also be balanced. What about the oxygens? I have 2 oxygens. I have 2 oxygens. I have 2 oxygens. So the equation is now balanced on both sides. I hope, guys, you see how that one works. Now we move on to E. Here on E, you will see that I have 1 sulfur, 1 sulfur. Sulfur is okay. And then I have 2 oxygens plus 2 oxygens. That's 4 oxygens on the left. But on the right, I have 3 oxygens. So my equation is actually not balanced. How am I going to balance it? Crisscross. I'm just going to put, since I have 2 this side, I'm going to put 2 over here. If I put 2 over here, how many oxygens do I now have on the right? I have 2 times 3, that's 6 oxygens. And now I also have 2 sulfurs. So I have to balance the sulfurs. I have 2 sulfurs this side, so I also have to add a 2 here. But look at what this 2 does. It makes me have 2 sulfurs on the left, 2 sulfurs on the right. Then how many oxygens? I have 2 times 2 oxygens. That's 4 oxygens plus 2 oxygens. That's 6 oxygens, because it's 4 oxygens plus 2 oxygens, which is equal to 6. And this side I have 2 times 3 oxygens. That's 6. So the equation is now balanced. I hope, guys, you get that. And now let's have a look at this one, F. For F, I have 2 hydrogens, no problem. But look at the oxygens. I have 2 oxygens on the left, but I have 3 oxygens on the right. How am I gonna get them to balance? All I have to do, guys, is to add a 2 here. I'm gonna add a 2 here. If I add a 2 here, you will see that I'm gonna have 2 times 2 hydrogens. That's 4 hydrogens that I have now. So this means I would also have to add to this side, so that I can also have 4 hydrogens. Now you will realize that when I say 2 times 2 hydrogens, that's 4. 2 times 2, that's 4. The hydrogens are fine. Let's check the oxygens. For the oxygens, I have 2 times 2 oxygens. That's 4 oxygens. This side, I have 2 oxygens plus 2 oxygens. That's 4 oxygens. The equation is now going to be balanced. Okay, let's go to G. For G, guys, we have 2 chlorines, 1 lithium, 1 lithium. Chlorines are not balanced, so I have to put a 2 here. Now I have 2 lithiums, 2 chlorines on the left, 2 chlorines on the, what am I saying? I have 2 lithiums, 2 chlorines on the right, 1 lithium on the left, 2 chlorines on the left. So the chlorines are sorted, the lithiums are not. So I have to also put a 2 here, since I have 2 on the right. Now I have 2 lithiums on the left, 2 chlorines on the left, 2 lithiums and 2 chlorines on the right. The equation is now balanced. Okay, we move on to H. When it comes to H, I have 2 nitrogens, 2 hydrogens. But on the left, I have 1 nitrogen, but 3 hydrogens. So what I'm going to do is to take this 2. Since I have 2 nitrogens on the left, I should also have 2 nitrogens on the right. So now the nitrogens are sorted, but when I check the hydrogens on the right, now I'm gonna have 2 times 3 hydrogens. That means I'm gonna have 6 hydrogens. However, on the left I have 2. So for me to have 6 hydrogens, I have to crisscross. I'm gonna take this 3 and put it up here. Now when I say 3 times 2, that means I'm gonna have 6 hydrogens on the left and 6 hydrogens on the right. The equation is now balanced. Okay guys, let's do I. Okay, for I have 1 potassium on the left, 1 on the right. So 1 chlorine on the left, 1 on the right. 3 oxygens on the right, on the left, and 2 on the right. So I have to make my equation balanced. What I'm gonna do, guys, is crisscross. The 2 will come this side, the 3 will come this side. Okay, that's what I'm gonna do. So I'm gonna put a 2 here, which is from this oxygen, and this 3 will be here, which is from this oxygen. Now let's check if our equation is balanced. I have 2 potassiums, 1 potassium on the left, 2 chlorines, 1 chlorine. So that means I should also put a 2 here. Now I have 2 potassiums on both sides, 2 chlorines on both sides. What about the oxygens? 2 times 3, that means I have 6 oxygens on the left. Then this side I have 3 times 2, that's 6. That means I now have 6 oxygens on the right. The equation, guys, is now balanced. I move on now to J. I think it's the last one. With J, I have 1. Okay, by the way, this I keep on forgetting to give the names of these substances. My bad on that, guys. So here we have NH4NO3. I have 1 nitrogen, 2 nitrogens. So with this one, guys, I can simply look at the fact that I have 2 nitrogens on the right but 1 on the left. So I can just put 2 here. When I put 2 there, it means I have 2 nitrogens on the left and I have 2 on the right. They are balanced. Let's check the hydrogens. For the hydrogens, I have 2 times 4. That is 8 hydrogens on the left. But on the right, I only have 2. So it means I have to balance here. By doing what? I'm going to take this number at the bottom, put it here, so that it becomes 4 times 2. 4 times 2 means I now have how many hydrogens? I have 8 hydrogens on the left and on the right. They are balanced. But let's look at the oxygens. For the oxygens, I have 4 oxygens plus 2 oxygens. That's how many oxygens? That's 6. And then this side, I have 2 times 3 oxygens. That's 6. So the equation now, guys, is going to be balanced. All right. That's how we do our balancing of equations. You check what is on the left versus what is on the right, and then you play with your numbers there. But you normally play with these ones at the bottom. They are the ones that you put as your coefficients. I hope, guys, you got this one, and I hope you did try to answer these questions as well. See you on the next video. Goodbye.